Example 3, going above and beyond CPCTC, or going beyond CPCTC. All right, so let's look at what they give us. They give us that AB is congruent to CD, BC is congruent to AD, and they would like us to prove that these lines are parallel to one another. So they want us to show that. Okay. Well, if those lines are parallel, then we would know that the alternate interior angles are congruent, which would be angle 1 here and angle 2 here. So in order to prove that the lines are parallel, I need to show that angle 1 is congruent to angle 2. And I would, in order to show that, because I know nothing about the angles from the given information, I'm going to use CPCTC, and I have to prove the triangle is congruent to do that. So in this proof, we will use the float proof method, and I'm going to write my congruency methods down that I have to choose from. Angle, angle, side, angle, and hypotenuse leg. Well, right from the beginning, I can see that these are not right triangles, so I'm going to get rid of hypotenuse leg. They gave me no information about any of the angles, so I'm going to get rid of angle, angle, side, angle. I don't have a shared angle, I don't have vertical angles, so side, angle, side is out. So the only possible method here is side, side, side. And I can see from my picture that I have a shared or common side, AC. So one thing I do like about the flow proof is that we can design this from the bottom up, and then from the top down, and so we can fill in the middle with whatever information that we need. So I've already kind of made a plan here, so I know my proof will end with DC parallel to AB. And how do I know that? I will know that because when alternate interior angles are congruent, then two lines intersected by a transversal are parallel. This is the converse alternate interior angle theorem if you like to state theorems. Again, most of us don't remember what the theorems are called or which one is which, so we're better off just stating what it is we're trying to say. We know that in order to show that they are parallel, we are going to show angle 1 congruent to angle 2. And we know we're going to do that through CPCTC. And what we know already is that to use CPCTC, I have to prove two triangles congruent. So I'm going to show that ADC is congruent to triangle ADC is congruent to triangle ADC. So we're going to have CBA. And I've eliminated all my other methods, so I know that my method that I'm going to use is side, side, side. So now that I have that information, I know where I'm going to set up 3 arrows. Each of them is going to give me a congruency statement about a side. They gave me 2 of them, so that makes it pretty easy. AB congruent to CD, that was given. BC congruent to DA, that was also given. So we just need our third side here. So we noticed on our diagram that AC is congruent to itself. That is our reflexive property, or a segment is congruent to itself. Reflexive property. And so now I have all my information. I have 3 congruency statements involving sides. I've proven the 2 triangles congruent, written my congruency statement with my corresponding parts. I proved that by side, side, side. My angle 1 and angle 2 are now congruent because the 2 triangles are congruent. Their corresponding angles, which are parts, are congruent. And because those corresponding angles are alternate interior angles, they are congruent. And because the alternate interior angles are congruent, the 2 lines must therefore be parallel. And that is it.